Number one, what is a force? Let's start with group one. Someone tell me, what is a force? Push or a pull? If this makes sense, if you push on something or if you pull on something, you're doing something to an object, and that's kind of what we think of as a force, doing something to something else. However, we need a better definition because there's a lot of things that don't feel like pushes or pulls. Gravity doesn't really feel like a pull, although I suppose it's pulling down on us. Normal force is the ground supporting us against gravity. That doesn't feel like a push, although I suppose it kind of is. When you spin in a circle, it feels like you're getting pushed out from the center, but that's not a force. There's a lot of things that look or act like pushes or pulls that aren't. And there's a lot of things that don't look or act like a push or a pull that are. So we need a better definition, and this is number 2. So go ahead and add this in here. So what's my better, more complete definition for a force? It's any action on an object that can, notice I didn't say does, cause an acceleration. Which an acceleration is a change in motion. Right? Acceleration is a change in velocity. So it can cause your velocity to change. That means it can cause you to turn directions, or it can cause you to speed up or slow down, or both. So forces have to be able to get you to change your velocity, which means they have to cause an acceleration. It doesn't mean they have to, they just have to be able to do that. Okay? That's what a force is. Gravity can cause you to change your motion. Okay? So gravity is a force. All right, let's jump to the back. Team 4. What is net force? Yes. I'm going to simplify that down a little bit. It's what you get when you do all those things, when you combine them all together. So it's the total force on an object. Okay, let's jump across the room. Group 7. How do you calculate it?
Force 1 plus force 2 equals net force.
Yeah. So you add the forces that are in the same direction. But here's something to be careful of. And subtract forces in opposite direction. Yes, and that's totally fine. Yes. And I was going to say that next. You're exactly right. If you're adding negatives, also fine. Yep. And that's really the way I'm going to think about it. I like to think about it as adding negatives because negative is the direction. You just want to be careful about that. So this would be 2 added together to get 10. This would be 5 plus a negative 5, which would be 0. This would be 10 plus a negative 5, which would be 5. So it's just your total amount of force acting on an object. Good. All right, let's jump up here to group 8. What's inertia? Good. Notice it didn't say tendency to resist motion. It says tendency of objects to resist change in motion. Okay, so it's resisting a change in motion. Okay, Newton's first law. I'm very picky about this, so I'm going to write it all out exactly the way I want to see it. You can change anything you need to on yours. And that's because Newton's first law is very, very, very detailed and very specific. So here it is. Objects in motion remain in motion at a constant velocity in a straight line and objects at rest remain at rest unless acted on by a non-zero net force. So there's three parts to this. Part one, objects in motion remain in motion at a constant velocity in a straight line That's the first part. So objects that are in motion stay in motion at a constant speed and in a straight line. Okay, second part. Objects at rest remain at rest. Third part. Unless acted on by a non-zero net force. So objects don't change what they're doing unless you make them change what they're doing. So unless you have an action that can cause an acceleration, you're not going to get a change at all. It's going to stay the same. All right, team 2 over here. Give me one of the examples from the book that you liked and that you thought was a good example of inertia. Yeah, the tablecloth trick. We're getting close to Thanksgiving, okay? Your parents will love it if you try this at home, okay? Wait for them to set up the nice dinner china, okay? Get the tablecloth on and just rip that sucker out from underneath of it. They'll love it. They'll think it's the funniest thing you've ever done in your life. Don't do that. I'm kidding. Don't do that. They won't like it. But the tablecloth trick works because of inertia. The plates and everything are sitting at rest on the table. If you pull the tablecloth, you apply a force to the tablecloth, not to the cups or the plates and all that stuff. They'll stay where they are. So that's a good example for the tablecloth trick. All right. Let me show you several examples that I have. We'll start with kind of a